Math 113, lesson 6.3 involves double angle and half angle formulas. So these are not formulas that you have to memorize. Even on the final exam, I will give you these formulas. However, they will not be titled as double and half angle. So make sure that you can use these, but make sure that you know which one is which. Okay, so I'm going to start by listing our formulas here. Double angle means an angle times 2. That's what it means to double. All right, so the formula here for the sine of 2 theta would be 2 times the sine of theta times the cosine of theta. Right, the cosine of 2 theta is cosine squared theta minus sine squared theta. Now, this particular one can be manipulated in a couple of different ways. So there's actually 2 others for the cosine of 2 theta. Another one is 2 cosine squared theta minus 1. And then the last one for cosine 2 theta is 1 minus 2 sine squared theta. All 3 of those can be used for the cosine of 2 theta depending on the information that is given to you. And then our last one would be the tangent of 2 theta is 2 times the tangent of theta divided by 1 minus the tangent squared of theta. All right, our half angle formulas look really nasty, but they are half, which means they are fractions, okay? So alpha divided by 2, I could have written theta, but alpha divided by 2. So it's plus or minus 1 minus the cosine of alpha divided by 2. My alpha didn't look so good there. Okay. My cosine of alpha divided by 2 is plus or minus the square root of 1 plus the cosine of theta, divided by 2. And then tangent of alpha divided by 2 is plus or minus the square root of 1 minus cosine alpha divided by 1 plus cosine alpha. And sometimes a little bit more friendly version of the tangent of alpha divided by 2 is, there are 2 other versions of this one. 1 minus the cosine of alpha divided by the sine of alpha. That gets rid of our square root, but it also requires that we know both sine and cosine to use that one. And then there is one more for tangent of alpha divided by 2, and it is the sine of alpha divided by 1 plus the cosine of alpha. So all 3 of those for tangent result in the same final answer, just like for cosine 2 theta. They all result in the same final answer. So these are not formulas you have to memorize. Please don't panic there. You do need to write them down, have them handy, have them beside you. Now on the final exam, you don't get to write anything down. I will provide you with a list of formulas, but you will not get to have any extra paper there with you that you have written on. Okay, so these formulas, you do not have to know how to derive them. You just have to know how to use them, apply them. All right, so make sure you have these written down and they're beside you, so as I go over some examples, you know where I'm getting my information. All right, so example number 1, our directions are going to be find the exact value. Remember, our calculator doesn't do that for us. Find the exact value of the cosine of 15 degrees minus the sine of 15 degrees. Now, if you type that in your calculator, you're going to get some crazy decimal, and that's not what we're looking for. Exact value means no calculator. All right? So we need to figure out what in the world does this mean. I don't know if these disappeared or if I never read them. Okay, so cosine squared of 15 degrees minus sine squared of 15 degrees. So if I look at the formulas that I provided for you, okay, this actually would be something on the right-hand side, cosine squared minus sine squared. If I look at my formulas, there it is, right there. Cosine squared minus sine squared is the cosine of 2 theta. Okay, so to work this problem, to find the exact value, then really all this is saying is the cosine of 2 times 15, because our theta in this case is 15. So the cosine of 30 degrees, which we can do from the unit circle or the hand trick. And we end up with the square root of 3 over 2. That would be our solution. So that's one example of a kind of problem. All right. Let's say this time I give you a triangle. We're going to let theta be right there. And my question this time is, let's find the sine of 2 theta. Let's find the sine of 2 theta. Well, we've got to first of all know that formula, okay? The sine of 2 theta. In order to do that, we have to say 2 times the sine of theta times the cosine of theta. Now we're going to use our triangle to help us figure out what is the sine of theta and the cosine of theta. Okay, so if I look at my triangle over here, the sine of theta, remember, is opposite over hypotenuse, so that would be 5 over 13. Awesome. The cosine of theta would be adjacent over the hypotenuse, and in this case, I don't know the adjacent side, so I need to do Pythagorean theorem to help me find that missing side. For the moment, we will call it x. So x squared plus 5 squared is 13 squared. Subtract that 25, and I get that x is 12. Square root of 144 is 12. Okay, so now I know this side is 12. So the cosine of theta is the adjacent over the hypotenuse. So now I come over here to my formula, and we multiply 2 times the sine of theta was 5 over 13. The cosine of theta was 12 over 13. So I multiply those things together. Think of that as 2 over 1. So 2 times 5 times 12 is 120. And 13 times 13 times 1 is 169. So the sine of 2 theta is 120 divided by 169. Don't try to give a decimal. We're wanting an exact value, and this is how we come up with that exact value. Okay, no triangle this time, or at least not that I'm giving you. If the sine of theta is 4/5 and theta lies in quadrant 2, okay, that's going to be important. We are going to find the exact value of each of these questions. Okay, question A, the cosine of 2 theta. Question B, the tangent of 2 theta. Okay, and so all I've given you is the sine of theta is 4/5. All right, so remember there are 3 formulas for the cosine of 2 theta, and you could use any of those formulas for the cosine. All right. So since all I was given was sine, how about I use that formula? The one that involved sine, which was 1 minus 2 sine squared theta. That's going to require the least amount of work on my part because I know sine. Sine is 4/5. So I put 4/5 in there, and it does say sine squared, so I have to square 4/5. Okay, so let's follow my order of operations. 16 over 25. Okay, we do have to do the arithmetic here and make sure that we get the correct answer doing our arithmetic. So I get 1 minus 32 over 25. Okay, now I need a common denominator. So 25 over 25 minus 32 over 25 gives me negative 7 over 25. So the cosine of 2 theta is negative 7 over 25. Awesome. Now I do need to make sure that I paid attention to the fact that theta was in quadrant 2. Okay, in quadrant 2 the sine is 4/5. Okay, well that was given to me, so that doesn't change anything because they gave me the sine was 4/5. I don't have to think my way through that. That would be my solution. Okay, let's do the tangent. All right, now for tangent of 2 theta, you were not given several formulas. That was for the half angle. All right, so our formula for tangent of 2 theta is 2 times the tangent of theta divided by 1 minus the tangent squared. Okay, so both of these require that I know the tangent, and remember the only thing I was given was that the sine of theta was 4/5. That's all I was given, and we are in quadrant 2. Okay, well I know sine is y over r, so I know my y value is 4. I know my r value is 5. Now in quadrant 2, we do know that y is positive, but in quadrant 2 we know x is some negative value, so we do have to remember that. So I need to solve here. Remember we've got our little r is equal to the square root of x squared plus y squared. So let's use this to help us find our x value. We do need to know x. My y value is 4, so 4 squared is 16. Square both sides. So I get x is plus or minus 3, but remember we're in quadrant 2. So x does have to be negative in quadrant 2, so x is negative 3. Now I'm able to find my tangent because tangent is y over x. Okay, so our y value is 4 and our x value is negative 3. It does matter that we have that negative there. All right, so now we've got what we need to plug into our formula. So 2 times the tangent of theta, so 2 times negative 4/3 divided by 1 minus negative 4/3 squared. Now we have to just do the arithmetic to finish solving that. All right, so when I multiply, I get negative 8/3 divided by 1 minus 16 over 9. Okay, I do have to do the arithmetic here. I'm going to do the denominator first. Okay, I know I need to get a common denominator. So negative 8/3, sorry about that, divided by negative 7/9. Okay, a fraction divided by a fraction, that's where we multiply by the reciprocal. Okay, and that can be simplified. 3 goes into itself once, into 9 3 times. Negative times negative is positive, so I get positive 24 over positive 7. So the tangent of 2 theta is positive 24 over 7. No decimal. All right. So we've done a few examples with our double angle. Let's do something with our half angle. So example number 4. So I will specifically tell you I want you to use a half angle formula. to find the exact value of the tangent of 75 degrees. Okay, if we have to use a half angle formula, well, theta is not 75. Okay, theta, or in this case, we'll call it alpha because that's what I did before. Alpha divided by 2 has to give me 75. So that means that alpha right here has to be 150. That way, 150 divided by 2 does give me the 75. So the alpha in my problem is 150. All right, now with half angle formulas, remember we were given a variety of equations, right? I am going to use this one. Didn't mean to put that in right there. Okay, so I gave you 3 formulas for the half angle formula for tangent. I am choosing to use this one. I really don't have a reason. I just want to use that one. Okay, so I've got to do 1 minus the cosine of 150. Notice I use 150 for my alpha. Alpha is not 75. That's where people usually go wrong here. Okay, now I'm not using my calculator. Okay, this is an exact value, so I have to find what in the world is the cosine of 150. Well, we learned that earlier in the semester. To find the cosine of 150, I really have to use a reference angle. Okay, here's 150. I need to know the reference angle, in this case, which is 30. My reference angle is 30. So the cosine of 30 degrees, I can use my little hand trick or I can use the unit circle. The cosine of 30 is the square root of 3 over 2. But 150 is in quadrant 2. So the cosine of 150 is negative square root of 3 over 2. Okay, so we've got that value. Now we have to find the sine of 150. Again, we have to start by doing the sine of the reference angle. In this case, that would be 1/2. And in quadrant 2, the sign is positive, so the sign at 150 is 1/2. Now I'm ready to plug those into my formula. So I've got 1 minus negative square root of 3 over 2 divided by 1/2. Now you do have to go through the arithmetic here. Okay, the first thing I'm going to do is that little minus negative should be a plus. All right, now nobody likes to see a fraction in a fraction. So I am going to start by multiplying my entire numerator times 2 and my denominator times 2. I can do that as long as I do it to the top and the bottom. All right, so when I do that, that leaves me with 2 plus the square root of 3 divided by 1. Oh, that's nice. That's 2 plus the square root of 3. So the tangent of 75, that was the question, the tangent of 75 degrees is 2 plus the square root of 3. Not using our calculator. Now, I could have used one of those other formulas, okay, for tangent of theta divided by 2. We will eventually end up at exactly the same answer. So I don't want you to think using one of them is the best way. We would have gotten the same answer. So all of section 3 is just being able to use these formulas and then do the algebra, the arithmetic, without that calculator and being able to show your arithmetic. And we can't forget our skills about reference angles and the unit circle. So please let me know if you have any questions.